Hello, my name is Jared Skeens and welcome to the Zoom room. Today we want to look at Pure Maths 3, Future Algebra, Part 6, Binomial Expansion. Now, binomial expansion is a little technical, a lot of details, very tedious with lots of steps to it. But if you really focus on it, you can get it down. It is sometimes a standalone question, but usually it's a follow-up question after partial fractions. We'll look at that a little bit later. But first, let's introduce you to how this binomial expansion is different from other binomial expansions you've been exposed to. So at the beginning, you probably learned as you were starting to expand. Remember, expansion in algebra means multiplication. So as you learn how to multiply terms together and things like that, you come across a binomial expansion. Binomial means two terms, and we're expanding it via multiplication. And so you might take an x plus 3 squared, which we know is two factors of x plus 3, and we have a distribution pattern to help us multiply it out. I like to call it the smiley face method. Some people use FOIL method, first, outers, inners, last. But whatever method you learned, it's some sort of a distribution pattern that allows us to very quickly come up with the answer. So we would put x squared plus 6x plus 9. Usually when we're working with quadratics, we write it in decreasing exponential order from the highest to the lowest. But for the sake of today's video, we're going to write it in increasing exponential order. So we'll put it 9 plus 6x plus x squared. So this is probably your first introduction to binomial expansion. Then at some point you get to the Pure 1 math book, and in the unit on series, you look at binomial series, which is another form of binomial expansion. And if we take the same thing, x plus 3 squared, and by the way, this formula for the binomial series is in your Cambridge formula sheet. And we use, the formula sheet actually uses Pascal's column vector, but you can also replace it with your NCR key on your calculator. So if you have an exponent of 2, you have 2c0 with this first term to the second power, the last term to the 0 power, and then 2, 1 with exponents of 1, 1, and then 2, 2 with exponents of 0, 2. So here you see the exponents decreasing from the front, and the back one is increasing by 1, and you see 2, 0, 2, 1, 2, 2 for your coefficients. This is all in the binomial expansion that you learn in Pure Maths 1. And when you calculate those out and simplify it, guess what? You end up with the exact same thing. Then we move now into Pure Maths 3, where we get into binomial expansion again, and we're going to use this formula down here. So this formula down here starts with 1 plus x raised to the nth power, and this formula is also in your formula sheet. So basically, it's just a skill of following through the formula. But again, it's quite tedious. You got a lot of signs, a lot of numbers, fractions, multiplication, exponents, all of that division is in here. And it follows this pattern. We'll talk about this statement over here a little bit later. So notice, again, there's a pattern to this. You start with 1, which is this one right here. You kind of notice that if you use the NCR key in your first term, you're going to get a 1. And if we take 1 to the nth power, it is still 1. and the x to the 0 power is still 1. So you can kind of follow this here to see how it comes up to this first term. Then it goes to n over 1, which is just n, but it helps you to see the pattern if you put n over 1 times the x plus, and notice the pattern up here, n times n minus 1, n times n minus 1, n minus 2. So this top number is decreasing by 1, and the bottom number is increasing by 1. So 1 times 2, 1 times 2 times 3. And your x term, whatever the x term happens to be, to the 0 power, first power, second power, and third power. And it continues on indefinitely. Okay, so this is the formula that we're using. So if we come back and apply that here, we're going to have to make some adjustments to make it fit the pattern, because it needs to be 1 plus something. So we're going to first switch it around so that the number is first. Then we're going to divide that number out of the parenthesis. So if we remember, factoring is division. So 3 divided by 3 is 1, and x divided by 3 is x thirds. You can see if you multiply it back in, you'll get the 3 plus x. So we do that inside the parenthesis. Then we apply the exponents. Exponents distribute to multiplication. So that exponent goes to the 3 and it goes to the 1 plus x over 3. The 3 squared then becomes 9. And now at this point, we have finally got it into a form that fits the formula. So we have 9 in the front times, here is our 1 that we're starting with. Our n is a 2, so 2 over 1. And our x is actually the x over 3. So this x in here is really referring to the second part of this binomial, the second term in the binomial. So we have x over 3 plus 2 times 1 on top. Notice that the second number decreases by 1, and on the bottom it increases by 1. And now we have x over 3 squared plus 2 times 1 times 0 over 1 times 2 times 3. And we have x over 3 cubed. Now notice at this point that we've had a 0 enter into our product. And this is going to continue on indefinitely, that every term from here on is going to have that 0 in it. And that 0, of course, is going to cancel it out. So actually our thing that we're solving for here actually will stop here, because all of these zeros will cancel out the remaining terms. So we have 1, we have 2 thirds x, and these 2's and 1's cancel, and we get x over 9, x squared over 9, and then we distribute the 9 through it, and what do you know, we get 9 plus 6x plus x squared, which is the same thing that we got in these other methods. Now, you might say, why in the world do I want to do something this complicated when I can just do this simple one? Well, this one up here is very specific to quadratics, binomial expansion with exponent 2. It's quite a simple multiplication, and so this distribution pattern helps us to do it very quickly. We can even do it in our heads. But let's say you have an exponent of 7. So maybe your exponent is 7 instead of 2. That means you have x plus 3 times x plus 3 times x plus 3 times x plus, you have 7 of those. Well, obviously there's not a simple distribution pattern for 7 binomials. That is where this formula comes in here. It is for positive integer exponents. So if we had a 7th power, notice with a second power, we end up with 3 terms. So if we had a 7th power, we would end up with 8 terms, okay? And we could use this, we would have 7C0, 7C1, 7C2, all the way to 7C7. And this would go from 7, 0, 6, 1, 5, 2, 4, 3, all the way to 0, 7. And we could actually figure out all 8 terms using this formula. This formula is nice to find specific terms in that elongated binomial expansion. So what is this one for? The one that we're learning today is for non-positive integer exponents. Non-positive, actually just non-positive exponents. It doesn't even have to be integer. Okay, it's for non-positive integer. In other words, the non goes, your positive integer goes together here. It's not a positive integer, let's put it that way. A not positive integer exponent. So in other words, it could be a negative integer or it could be a positive fraction, but not an integer. Okay, so this is for not positive integers. Why? Well, notice when we decreased by 1, we ended up with a 0, which cut off all the other terms, which was fine for something like this. But what we're looking for is where this list continues. You don't get that 0 in the product. So if we started instead of with a positive 2, let's say we started with a negative 2, you would have negative 2 here, and here you would have negative 2 times negative 3 because you decreased by 1. So it would become more negative. So you would never reach 0. You'd just get more and more negative. So this will go on indefinitely. Or instead of a negative integer, maybe we have a positive fraction. So if we start off with 5 halves, and you decrease by 1, you get 3 halves, and you decrease by 1, you get 1 half, and you decrease by 1, you get negative 1 half, and so on. But again, you don't end up with a 0 in the product. And so your answer actually continues indefinitely. Obviously, we're not going to go indefinitely. Usually, Cambridge has you take it to the x squared term. In other words, you're going to usually end up with 3 terms or maybe 4 terms, but probably not much more than that. Usually it goes to the x squared term. Okay? So what that means is that because this goes on indefinitely, this then is an approximation of the original that you started with. That is where this statement here comes in. Because it's an approximation, you can't just plug in any value that you want and expect it to be accurate. So what this helps you with is it helps you know the range of values that you can plug in for x and still end up with a reasonable approximation for the original. Okay, so we'll talk about that in just a minute, and I will set up for our first example problem. Okay, let's look at our first question. Our first question is a standalone question. Says, and you can see the code up here. Notice it does come from the new Summer 20 past paper series, paper 31. So this is in the new syllabus. So in the new syllabus cycle already, they do have, it does occur as a standalone. So it says expand 2 minus 3x to the negative 2 in ascending powers up to x, up to and including x squared, simplify the coefficients. And then for part B, it says state the set of values of x for which the expression is valid. Okay, let's go back to our board. Here I already have the question written down. So remember, this is a multi-step, very detailed and kind of tedious work. So you want to have your mental strategy down. So I'm going to walk you through it here. So first, we want to move, switch this around. So instead of 2x minus 3, oh, I'm sorry, I have this wrong. It should be 2 minus 3x. Okay, 2 minus 3x. We don't have to switch it around. The number's in front and the x is in the back. That's what we want. Remember that the pattern starts off with 1 plus x to the n. So you want to, first thing that you want to do is make your original to fit this pattern, 1 plus x to the n. We want the 1 in front, the x in back. So since the number is already in front, we're just going to divide it out, factor it out. So this is going to become 2. We're factoring it out. So 2 divided by 2 is 1 minus, and when we divide this by 2, we get 3 halves x. And then the negative 2 is on the outside. So we factored the inside. So now that we have that 1 in the front, now we can distribute, because this is multiplication. Exponents distribute to multiply. Exponents do not distribute to add and subtract. So it does not go within the parenthesis, but it applies to the number in front and to the parenthesis in back. So this becomes 2 to the negative 2 times 1 minus 3 halves x to the negative 2, which equals 1/4. So remember, the negative flips it over as a fraction, and now you have 2 squared in the denominator, which is 4, and you have 1 minus 3 halves x all over negative 2. So this negative 2 stays up there. We don't want to make that a fraction. So this, now we have the 1/4 in front. That's just a coefficient. It's okay. We have 1. Don't worry about the plus or minus. Remember that the sign goes with the term. So this x here is the negative 3 halves x in this binomial, and we're going to expand it. So now we go into the formula part. So we have 1/4 times 1, and we're following the formula that's in your formula sheet. So make sure you follow along your formula sheet so that you can understand the pattern. The first term is 1, and then we get our exponent n, negative 2 over 1, and the formula sheet just says n, because divide by 1 is still negative 2, and then our x is a negative 3 halves x, and plus, and we go back to our negative 2 and multiply it by n minus 1. So here's n times n minus 1 over 1 times 2. So the top numbers decrease by 1, the bottom numbers increase by 1. Then we have our negative 3 halves x squared, and that's as far as we need to go because it says to only go up to the x squared term. So if we simplify this, we get 1/4 still out in front. We wait on that we don't want to distribute it right away. Here's 1. Now here, the 2's and negatives cancel, and so we're just left with 3x. And then over here, the 2's cancel, the negatives cancel, the square on this negative cause this negative to cancel, and we get 9/4 x squared. And then this will equal, now we can distribute the 1/4. 1/4 plus 3/4 x plus 9 over 16 x squared. And this is the expansion, 1/4 plus 3/4 x plus here, this one should be, just a second. Okay, I see my mistake. Like I said, this is very tedious. You got to really pay attention to the details. Right here, we're supposed to decrease by 1. Negative 2 decreased by 1 is not negative 1, it is negative 3. So I made a mistake right there. Negative 2 goes down, negative 2 times negative 3, which means this then, the 2's cancel, 3 squared is 9. these 2's cancel. 3 squared is 9 times 3 is 27 over 2 squared is 4. And so this should be 27 over 16ths. So already in the first example, I've already made a mistake, but that's why you train your mind what to look for so that you have your pattern, your way of working through it. Also, so that you can find your mistakes when you make one, but you have to really pay attention to the signs. Make sure you're going down on the top, up on the bottom, and of course your orders of operations, everything. So this is our correct answer here. 1/4 plus 3/4 x plus 27/16 x squared. That is the binomial expansion up to the x squared term. Remember, this does continue on indefinitely. There are other terms. So if you're wanting to approximate this value, you can use, obviously the more terms you use, the closer the approximation will be to the actual. But you'd be surprised that you can still get within 3 significant figures of accuracy with relatively few terms if you follow that that guideline of the absolute value of x being less than 1. So that was part B. Part B was basically to verify or find the set of values where this would still be an accurate representation of the original. So this here comes with the absolute value of x less than 1. So what we want to look for is right before we expand it, we want to find that x term. This is a 1 plus x. So what is that x term? 1 followed by what? And we have a negative 3/2 x. Now, since this is absolute value, we don't need the negative. So basically, we have 3/2 x less than 1. If you want to put the negative in, you can, but it doesn't really matter. And then we want to get rid of that 3/2, multiply it to the other side. So we're going to get the absolute value of x is less than 2/3. It was only a 1-point question. And what it wants you to do is take that x part. I'd probably leave out the negative since it's absolute value. And then solve for the absolute value of x. It's wanting you to make the connection between this guideline for having an effective answer or a close enough approximate. And so for this polynomial here, if your x or absolute value of x is less than 2/3, you should end up with a reasonable approximation for this up here. And you can try it. Maybe you want to try plugging in 1/2. 1/2 is less than 2/3. Plug in 1/2 up here. See what you get on your calculator. Plug it in here. See what you get on your calculator. Maybe you want to try finding a 4th term or 5th term and see how the accuracy improves with the more terms that you have. But this is your guideline for finding the set of values that will help to make this more accurate with respect to the original. So this verify or this find the set is not as common, but if they ask it, you should know how to handle it. Now let's look at the same question of this binomial expansion, but as a follow-up to a partial fraction. Okay, let's look at our next example here. And maybe you remember this from our part 4 video series where we did partial fractions with the simple and repeated factors in the denominator. So we actually already did this one together in the part 4 video. And here you have your 8x squared plus 9x plus 8 over 1 minus x times 2x plus 3 squared, and it says expressed in partial fractions. You can go back and look at video 4 if you want to watch that. We're going to move on then to the follow-up question, which then says to hence obtain the expansion of f of x in ascending powers of x up to including the term in x squared. Notice that this is 5 points, so you have about 7 minutes to do this. So let's go back to the board, and I've written the original here from part I. I've also written the answer that we already got from that partial fraction. So instead of doing that over again, you can refer back to the part 4 video on partial fractions with simple and repeated denominators. And so this was our answer from that part, which is why you need to make sure you get that correct, because now you're going to move forward into the next phase, which is the binomial expansion. So now we've got 3 fractions, not just the one like we looked at in the first example. So we're going to have to, again, mentally get your strategy down here and go step by step. Don't try to skip. Don't try to do it in your head. Just carefully work through all the steps. So the first thing we want to do is we want to bring these denominators up and put it into an exponent form. Again, we want to make it match the form for the formula. So this is going to be a 1 minus x to the negative 1. So we move it up to the numerator and change the exponent. Minus 2 times 2x plus 3 to the negative 1 plus 5 times 2x plus 3 to the negative 2 power. So now we've got them all up into the numerator. Now we need to make sure that the first term is 1. In fact, with these two, I'm just going to go ahead and switch them around to 3 plus 2x. 3 plus 2x. We want that number in the front. Okay, so now we're going to factor these. This one is already okay. We already have a 1 in the front. So this one we don't have to do anything with. This one we need to factor out the 3. So we're going to factor out the 3 from these. That gives us a 1 plus 2/3 x to the negative 1. Again, remember that factoring is division. 3 divided by 3 is 1. 2 divided by 3 is 2/3. So we're factoring or dividing the 3 out so that we have that 1 in front of our binomial, plus 5 times, and this is the same thing, take out the 3, 1 plus 2/3 x, and this one is to the negative 2nd power. Okay. Now we want to distribute the exponent. This is a multiply. We want to distribute the exponent to this multiplication. It does not distribute to the add and subtract on the inside of the parenthesis. It does distribute to the multiplication. So this becomes 1 minus x to the negative 1 minus 2 times a 3 to the negative 1 times 1 plus 2/3 x to the negative 1 plus 5 times 3 to the negative 2 times 1 plus 2/3 x to the negative 2. And this then equals, again, we have this part here. I'm going to write it a little up here. Might have to take 2 lines here. 1 minus x to the negative 1. And this is 3 to the negative 1 means it's 1/3. So this is a minus 2/3 times 1 plus 2/3 x to the negative 1. And then plus, and this is 3 to the negative 2, means this is 1/9. So the negative makes it go below the division bar. The square makes it turn into 9. So this is 5/9 times 1 plus 2/3 x to the negative 2. Okay. Now we're at the point where we can actually use the formula. So all of this work here was just steps to take to get our binomial into the formula form. Okay, so a lot of work just to get it into formula form. And if you pay attention to those steps, it's the same steps every time you do it. Once you learn how to do it, you follow the same mental procedure every single time. So it's worth the effort because this is a 5-point question, significant number of points on your test. It takes a little practice, but once you get your mental strategy down, it's just repeat, same thing over and over again. Okay, so let's start the formula. So for this first one, we have 1 plus our exponent is a negative 1 over 1 times our x is a negative x. Don't forget to include the sign with the term. Plus a negative 1, and we go down 1, so that would be times negative 2. And on the bottom, we go up 1, so it would be 1 times 2. And this will be a negative x squared. And we've already reached the square term, so we can stop the expansion of this first one. It does keep going, but we're stopping at the x squared term. Then minus 2/3. And then we do this expansion. So 1 plus a negative 1 over 1, and now our x is a 2/3 x to the negative 1, and then plus a negative 1 times negative 2, so the top goes down 1, the bottom goes up 1, and we have a 2/3 x now squared, and we've reached the end of this one. Then plus 5/9 times 1 plus, now we have a negative 2, so negative 2 over 1 times 2/3 x plus a negative 2 times negative 3. That was the mistake I made in the first example. I went from negative 2 up to negative 1. We need to go down. So negative 2 times negative 3. And this is 1 times 2. And that's multiplied by a 2/3 x to the negative, or to, sorry, squared power. So this is squared. And that's the end of that one. So let's see if we can simplify this out. Don't distribute these yet. Simplify inside of these big parentheses. So in this one we have 1. Here we have plus x. Here the 2's cancel, the 1's cancel, the negatives cancel. This negative cancels with the squared, and we just get plus x squared. That's that one. Minus 2/3. 1. Here we have, sorry, this is not to the negative 1 power, it's just to the 1 power. We don't even really have to write it, it's just 2/3 to the 1. And so we end up with a negative 2/3 x. And here the 1's cancel, 2's cancel, negatives cancel, and we have a plus 4/9. Don't forget to distribute your square to all those numbers in the fraction. 4/9 x squared plus 5/9 times 1. Here was a negative 4/3 x. And plus the 2's cancel, we get a 3 times 4/9. So 3 times 4/9 is 12/9 x squared. So we got that far there. And we see that now we have What else do we have here that I need to check? Okay, everything is correct so far. And just this 12/9 can reduce, if we divide by 3, we can get 4/3 here. So 12/9 is correct, but we can reduce it to 4/3 to kind of simplify that down a little bit. Okay, now we want to distribute through, or distribute these through. So we get 1 plus x squared minus 2/3 plus 4/9 x minus 8/27 x squared. By the way, you will get ugly fraction numbers. It doesn't all come out to nice, neat numbers. Plus 5/9 minus 20/27 x plus 20/27 x squared. And so now once you've distributed, what you want to do is just take your calculator and combine like terms. So the 1 and the 2/3 and the 5/9, you want to do that. And when you come up with that, the 1, the negative 2/3 and the positive 5/9 comes out to 8/9. And then you take the 1 and the 4/9 and the negative 20/27 and you combine those and you get 19/27 x. And then you look for your x squareds. 1 minus 8/27 plus 20/27, and that equals 13/9 plus 13/9 x squared. And so this is our binomial expansion up to the x squared term for these 3 fractions here. So it is quite lengthy, very tedious, very detailed, and you have to think through it step by step. If you look at the whole thing, it's very confusing, but if you learn to think about what you're doing and why you're taking the steps, you still have to be careful of those sign mistakes and make sure you're combining things correctly. But you can work through it step by step. It might take you the full 7 minutes. It might take you 10 minutes to do the question. Carefully work through it, but it's worth it if you get the 5 points out of it. Hopefully, if you look at kind of the shorter way I taught you how to do this, this is supposed to be 7 minutes. If you can do that in 5, that gives you the couple extra minutes to put down here on this follow-up question. So both together could take 15 minutes, and if you can spend 5 on the first part and 10 on the second, you can get 5 points for both. That's 10 points. That's a major part of your test. It's well worth to invest it, but you really got to have your mind set down on the steps to follow through. So we're going to do one more example. We're only going to have time for one more because it's already quite lengthy, but I'll set up for one more so that you can see it one more time. Okay, here's our last example. Let's look at it first so you can see it. Again, here's the code up here. We also did this one. You can see that this is simple and repeated factors. We also did this in video 4, so you can look back at that. For this part, where we had partial fractions, and then it says, hence obtain the expansion in ascending powers of x up to and including the term in x squared. Again, it's 5 points. So we're doing the same thing. This time, what I'm going to do is I'm going to tell you the step. If you're taking notes, you might want to write down steps to take so that you can start developing your mental focus. And then after you write down the step, then try to do it and see if you get the same thing. So the first step that we're going to take is we're going to bring the denominators up into the numerator. So we get 1 minus 2x to the negative 1 plus 3 times 2 minus x to the negative 1 minus 2 times 2 minus x to the negative 2. So step number 1 was bringing all the denominators up into the numerator. Step number 2 is to make sure that the number is in the front. We want the number of the binomial in the front, and it already is. We don't have to switch anything around, so you want to make sure you have that. Number 3, we need to factor these factors. We need to factor them so that there's a 1 in the front. Okay, so factor so that there's a 1 in the front of the binomial. So that leads us to, this one is already okay, already has a 1. This one has a 2. This one also has a 2. Okay, so what we did here in this step is we made sure there's a 1 in the front. This one already has it. This one does not, so we're dividing by 2. 2 divided by 2 is 1. X divided by 2 is x halves, raised to the negative 1 power, and we did the same thing with this one here. Now what we want to do in the next step is to distribute the exponent. So when we distribute the exponent, what we're going to get is this. Better. Okay, so what we did now is we distributed the exponent. So this negative 1 went to the 2 and to the binomial. This negative 2 went to the 2 and to the binomial. So now we have the exponents distributed. Remember, exponents only distribute to multiply and divide. They do not distribute to add or subtract. Now let's simplify these coefficients in the front. So simplifying our coefficients in the front gives us, that one is already simplified. This is a 3 over 2. And this is a 1/4 times 2 is a negative 1/2. Okay, so we have that. Now we're ready for the formula. So bring the denominators up into the numerator. Make sure that you have the number in the front of the binomial and the x, the variable, in the back, the second position of the binomial. Factor out that coefficient from the front so that you end up with a 1 in that first term position of your binomial. Then distribute your exponents to the number that you factored out and to the binomial. Then simplify any coefficient with that number that you factored out. So simplify. Now we're ready for the formula itself. So if we go into the formula itself, I'm going to start back down here at the bottom again. So we do this one first. So it starts off with 1 plus a negative 1 over 1 times a negative 2x. Make sure you keep the sign with that second term plus a -1 times -2. The top decreases by 1, the bottom increases by 1. And so now you have a -2x squared, and that is all for this first term. Now we have a plus 3/2, 1 plus -1 over 1, and we have a -x/2 to the first power, plus -1 times -2 over 1 times 2, and a -x/2 squared. We're done with that one. Minus 1/2 times 1 plus, now we have a -2 over 1 times a -x/2 plus a -2 times -3 over 1 times 2 and a -x/2 squared. Okay. So again, look at your formula sheet to help you work through that. Again, the more often you practice it, the faster you'll get, but you still need to be careful, so don't go too fast. Now let's simplify this out. 1 plus 2x, 1's cancel, 2's cancel, negatives cancel, we have a positive 4x squared plus 3/2, 1 plus x/2, 1's cancel, 2's cancel, negatives cancel, this one cancels, x squared over 4. Minus 1/2. 1, 2's cancel, negatives cancel, plus x. 2's cancel, negatives cancel. This negative cancels, so we have 3 over x squared to the 4th. So 3/4 x squared. There's a lot of numbers and signs, and don't forget the square goes to everything in the parenthesis. So you might want to take time to work it out. I see the 2's cancel, these negatives cancel, this cancels because of the square. You get x squared and 4 times 3, so 3/4 x squared. And we want to distribute these outside coefficients, so 1 plus 2x plus 4x squared plus 3/2 plus 3/4 x, and we distribute this, and 3/8 x squared minus 1/2 minus 1/2 x and minus 3/8 x squared. So that our final answer, so we're looking at the 1 plus the 3/2 minus 1/2 equals 2. And we have 2 for the x term, 2 plus 3/4 minus 1/2, and that equals 9/4. And we have 4 on the x squared term plus 3/8 minus 3/8 gives us just a plus 4x squared. So there is our binomial expansion up to the term with the x squared in it. And this is an approximation, not just for this here, it's also an approximation for this big, complicated looking fraction over here. So this fraction can be turned into this binomial expansion, or this polynomial that's expanded out. And it actually, don't forget, it continues on. You only need the first three terms there, but it does continue on. And again, pay attention to the values for which it is valid. In other words, not necessarily valid, but what values will give you, the set of values that will give you an accurate approximation of this original statement. So that's how to do binomial expansion. Again, the formula is in the formula sheet, so you don't have to memorize it, but you do need to practice it and come up with your mental strategy of how you're going to step by step work through it so that you can be successful at it. And yes, it is worth the time and effort to do so. And if you have extra time, you might want to play around with just seeing how accurate you can get by plugging in certain numbers. But I know you're probably just trying to stay up with the P3 curriculum at this point, and so you probably don't have a lot of extra time to play around. But thank you for joining me on in the Zoom room, and I hope to see you again next time.